third unit important topics. Let me discuss. Okay. Now I am sharing my screen to you. This is my screen. Okay. See here. Yes. Is it visible to you? Are you able to see?
Yes, sir.
Yes.
Okay. Okay. So, as usual, to explain about the important questions in third unit also, I am taking as the reference this question paper only, previous question paper. Last year, our senior students have been written this question paper as under the mid examination one. Okay. So, CIE one is nothing but mid examination one. This is the pattern already you know. And third question, third unit question where you will get, 1E, one short answer question like this you are going to get. Here itself, here you see CO3 is there, course outcome of the third unit. First unit two questions, second unit two questions, and in third unit one question can be expected in mid examination. This is only for mid examination only. Okay, so like this, we don't think that this question only will comes in the mid examination, don't think like that. But thing is, I'm going to tell what are the important questions that can be expected in unit 3. So this is a sample question paper like that you take. Okay, so compare the properties of direct and indirect band gap semiconductors based on EK graph. And also some extension is given that give one example to each semiconductor, direct and indirect band gap semiconductor properties based on a graph, and one example for each type of semiconductor. This is for 2 marks, and this question can be expected as under the 1E. Okay. Now, if you take set number 1, if you take where that third unit question will comes means, you see last you go one, if you take that is short answer questions. Two, if you take 2 and 3 from unit 1. 4 and 5 if you take. Fourth question and fifth question if you take. That is from unit 2. And this question 6A or B. Try to understand. Only one question as A or the other question as B. Any one have to be attempted to get these 3 marks. Any one. Compulsory one question have to be attempted. That is either 6A or 6B. In general, in mid examination, 6A will be the theory question. Means what is Hall effect? Derive an expression for Hall effect, Hall experiment, and list the applications of Hall effect. Regarding entire Hall effect, you have to write. The same question can be asked in final exam for 10 marks or 12 marks. Here, that marks whatever are carried, that is less marks only, but thing is here whatever the content that you have to write, that is complete content you have to write. That is very important. 6B, in general a problem will be given as like this, which is relevant to the that first unit, that first part, that is 3B syllabus if you take. Okay, so according to Hall effect, is the syllabus na? So this is the problem that you can expect, and like these problems can be expected. Already you have solved so many problems in unit 3A regarding the semiconducting materials, conductivity and resistivity and RH value, calculation of RH value as like this. If you take the second set also, if you take the second set also, two sets are there. Okay, 1E is the question what you can expect here. In set 1 you see direct and indirect band gap semiconductor properties were asked, and in that there is one more question was given, that is as under this here. I say direct and indirect band gap semiconductors is given, and as the 3 marks question Hall effect is given. Now, if you come to the second set, here this was given as under the short answer question. It doesn't mean that you have to reduce the content. Whatever content that you know, that you have to write. So Hall effect and list the applications of Hall effect. If you go to the sixth question, now you say discuss the properties of direct and indirect band gap semiconductors. Discuss means even in more elaborated manner you have to write the properties by using the EK graph, and you have to give some examples for each that type of semiconductor, indirect and direct band gap. Here don't consider the marks, only you see what question was asked and how much amount of content that you can present on that question paper, answer paper, that you need to see. Okay, so one question either this or this you need to write. Here you see concentration of charge carriers are given and asking you to find out the resistivity value, conductivity sigma equal to NIE into mu n and mu n plus mu p. Like this, there is one problem is there. That problem can be expected as under the second set. Okay, so 6a and b in general will deals with the unit 3 it deals with. Okay, so like this problems can be expected and the theory questions can also be expected. Now the thing is, under unit 3 what are all the important questions are there, that now we will see. First 2.5 units are the syllabus for the mid examination, that already you know. And under Unit 3, the first topic is intrinsic and extrinsic semiconductor properties, and P-type and N-type semiconductor properties, formation, and Fermi level and intrinsic and extrinsic semiconductors Fermi level, where it will be, and direct and indirect band gap semiconductor properties. All these are the topics in Unit 3 if you take. Okay, and Hall effect applications. Up to this, you can expect as under the questions in unit 3 in first mid examination. Okay, these questions are also there, but they will comes under the second mid examination. Okay, cannot be expected these for the second mid examination. These three topics relevant to the mid to actual. Okay, up to hall effect only is the syllabus. Now, Unit 3A, if you take, the important questions can be expected if you take all these as the topics in Unit 3A. Like this, if you take the topics, okay, which topics can be expected as the important questions means this one: intrinsic properties, extrinsic properties, and Fermi level in intrinsic and extrinsic semiconductors, N-type properties, P-type properties, and the direct and indirect band gap semiconductors and Hall effect. These topics can be expected as important questions. Green color, whatever the topic is there, can be expected as under the short answer questions in final exam, and the remaining questions can be expected as under the long answer questions. Sometimes they may also can be expected as under the short answer questions, long and short, red color questions. But very very important questions are direct and indirect band gap semiconductors and Hall effect and its applications. Green color, short answer question. Red color questions, long answer questions. Sometimes they are giving this question as under the short answer, then you have to manage the time and you have to write the answer accordingly. You have to write the answer, but overall these topics will comes under the long answer questions. Properties of and formation of N type, properties and formation of a p-type, and direct and indirect band gap semiconductor properties and Hall effect. So we have seen set 1 and set 2 are what, and unit 3 if you take, where that question will appear in set 1, and where that question unit which is relevant to the unit 3 appears in examination question paper as under the set 2, we have seen. Okay, now let me briefly explain unit 3, whatever the content is there in unit 3. Let me explain as like this: classification of materials. Three different types of materials, we know that conductors are there, insulators are, semiconductors are there. Unit 3 only. Okay, and this relevant to this is semiconductors. Intrinsic semiconductors are there, extrinsic semiconductors are there, and N type and P type are the different types of semiconductors under extrinsic. Okay, so that we already know. Definition of semiconductor: In those materials in which electrical conductivity is partial, we are calling such type of semiconductors as the such type of materials as the semiconductors. So energy band gap of semiconductors, if you take, it can be drawn as like this. Partial is nothing but gap is not as high as the insulators, gap is not as low as the conductors. In between, it can be seen as like this. Okay. And if you take the properties, these are all the properties. Electrical conductivity is partial, and the energy band gap is in between the conductors and insulators. And semiconductors, if you take at 0 degree Kelvin, they will behave as a perfect insulator. And as the temperature of the semiconductors will increases, electrical conductivity will also increases due to the increasing of the charge carriers. Such type of materials are called semiconductors. Like semiconductor properties we have seen, Eg value is small. Okay. So silicon and germanium, if you take, their energy gap value is 1.1 for silicon, 0.7 for the germanium material. Okay. That we have seen. Okay. Just I am reviewing the topics in unit 3a, semiconductors. Okay. Semiconductors are what? Now you know, intrinsic and extrinsic, their properties, and n-type and p-type formation. Intrinsic semiconductors, if you take, then atomic arrangement is like this. Intrinsic semiconductor examples are silicon and germanium. They are tetravalent. Silicon or germanium, if you take, they will have the four valence electrons at their outermost orbit. Now, silicon to silicon bonding is present. That's why we are getting a solid here. Actually, all atoms are they were they were one and each other are forming some bonding. That is nothing but we are calling it as covalent bonding. We are calling it as, all are pure silicon atoms only. No impurities are added. Then this is nothing but the atomic arrangement in silicon, like that we can say. Okay. So what type of bonding is present means covalent bonding is present. Intrinsic or pure are also called undoped, not at doped, undoped, we are calling them as. Covalent bonds are present as like this, and all the parent atoms are of same type, silicon atoms only. Okay. Now if you take the properties based on the temperature, when temperature is 0 degree Kelvin, all atoms are having the covalent bond, and no electron is of a free electron. So no free electrons are there means it is just like an insulating material. That's why it is behaving as a perfect insulator. All our covalent bonds are there. No free electrons are available. That's why conduction band in which free electrons in general we can expect, that is empty. No free electrons are there. Valency band in which all the bonded electrons are present. That's why this valency band is completely filled with the bonded electrons. No free electrons are available. That is the property of an intrinsic semiconductor at 0 degree Kelvin. When you raise the temperature of that intrinsic, then covalent bonds are breaking, EHP process is taking place, and free electrons are released by creating the holes. Holes are nothing but the vacancy sites which are created by the bonded electrons by absorbing the thermal energy which was given from outside. Okay. Due to that, few charge carriers are present here, electrons are present in conduction band, and the same number of holes are present in the valency band. Holes number is equivalent to the free electrons in conduction band. So Ne equal to number of electrons equal to number of holes, that is number of charge carriers. That is nothing but this energy band structure in intrinsic semiconducting materials. Okay. So EF is exactly located at the middle of the conduction band and valency band. Okay. Now extrinsic semiconductors, they are not pure, they are doped. Impure semiconductors, we are calling them as, we are adding some impurities like foreign atoms, arsenic, antimony, potassium, like that, phosphorus, parent atoms, one impurity atom will be added. So that is more than enough in a doping process. Okay. So impure semiconductors are nothing but they adding the impurities to a pure semiconducting material. It will form an extrinsic semiconducting material as like this. We are having two different types of extrinsic semiconductors, N type and P type. Formation of N type, if you take pure semiconducting material, we are adding the pentavalent impurity atoms to the pure semiconducting material. Then N type semiconductor is formed as like this. Okay, they are N type semiconductor. If you take majority charge carriers are electrons, we can expect as. Okay, due to EHP process, more and more number of electrons are creating when compared with the number of charge carriers as the whole. So majority charge carriers are electrons. And one more important thing is donor energy level can be expected in this n-type semiconducting materials. Donor energy level is nothing but when temperature 0 degree Kelvin, then whatever the extra electrons of this arsenic are there, they are occupying a particular energy level just below the conduction band. This energy level is called as a donor energy level. It is nothing but arsenic is always ready to donate free electrons even at 0 degree Kelvin. So that electrons are having a higher energy level than the valency band, but less than energy level of the conduction band. That's why that donor energy level is just below the conduction band. ED we are calling it as. When temperature is 0 degree Kelvin, this is going to be happen. Okay. Now, when temperature is raised of this n-type semiconducting material, then EHP process are taking place. Due to EHP process, charge carriers as the electrons and holes are generating. But initially, when you raise the temperature, then first by creating the holes, these charge carriers, electrons will occupy the ED level. Still further increasing the temperature, more and more covalent bonds are breaking, more and more number of holes are created, and these free electrons are occupying the conduction band. Overall, what is happening here? More number of free electrons are available at conduction band when you compare with the number of electrons in valency, number of holes in valency band. That's why Ne is equal to greater than Np, like that we are saying as. Okay, majority charge carriers are electrons. We can increase the electrical conductivity by either increasing the number of electrons or by increasing the number of holes. So in n-type semiconductor, we are increasing the number as electrons, more number electrons. Okay, and if you take the p-type semiconducting materials, their properties we have explained. I have explained by using again the energy band structure and the atomic structure. Overall, here what is happening? If you take a pure semiconducting material and adding the trivalent boron or gallium or aluminum, formed semiconductor is called p-type semiconducting material. By adding the impurity atom as here trivalent. Trivalent will have the acceptor energy level. Acceptor energy level is nothing but an energy level which always accepts the free electrons to occupy even at 0 degree Kelvin. Okay, so that's why this acceptor level is having the energy level that is just above the valency band. Ea is here, Ed is here in n-type semiconducting material. Okay, so Fermi level is exactly in the middle of these two energy levels as like this. Okay, so energy band structure can be seen as like this. Okay, and one more important thing is when you increase the temperature, what is happening inside this semiconducting material and p-type semiconducting material? More and more number of covalent bonds are breaking, and all these covalent bonds, breakage of covalent bonds, charge carriers are releasing, and first free electrons are occupying the accepted energy level, and still further increasing, these free electrons are still directly jumping to the conduction band. But thing is, initially they are occupying free electrons at this energy level, na? So here shortage of free electrons can be expected, and more number of holes can be expected at valency band. So majority charge carriers in the p-type semiconductor are holes, and minority charge carrier, here you see 1, 2, 3 free electrons are there. Here 1, 2, 3, 4, 5, 6. Example I am telling. More number of charge carriers are there. Hence we can say that Number of holes are the majority charge carriers in a p-type semiconducting material as like this. Okay, so that is about n-type and p-type material and their properties. Now, what is Fermi level and where it is located in n-type and p-type semiconducting materials, and even in at intrinsic semiconducting materials? If you take intrinsic semiconducting materials, Fermi level is nothing but at 0 degree Kelvin, the highest energy level that an electron can occupy in a particular system or in a material. That energy level is called as the Fermi level at 0 degree Kelvin. Now, intrinsic semiconductors, if you take, Fermi level is exactly in the middle of Eg. In the middle of Eg is nothing but Eg by 2 is nothing but the value of Ef. So we can write Ef equal to Eg by 2, where Eg is nothing but the difference between the conduction band to the valency band. That is Eg for energy gap, forbidden energy gap we are calling it as Ec minus Ev, Ec minus Ev by 2 as like this. Okay. Second one is Fermi level in n-type semiconducting materials, where it is located means exactly in the middle of Ed and Ec when temperature is 0 degree Kelvin. You have to draw the energy band gap energy band structures here. If you don't draw, even if you write the theory part of 100 pages is also waste only. So concentrate on the diagrams. Okay. Am I audible to you? Is it okay, students? Am I audible to you? Is it okay?
Yes, sir.
Okay. Okay. So here in n-type semiconducting materials, where is that Fermi energy level? Means it is exactly in the middle of these two. Na? So Ec plus Ed by 2. Simply we can write as like this. By 2 stands for here middle action. This energy plus this energy divided by 2 will give the exact middle value. That's why we are writing as like this. In p-type semiconductors, as we all know that it is exactly in the middle between accepted energy level and the valency band. So EV plus is nothing but EV is nothing but valency band. EV plus EA by 2 as like this we can write. Okay. Now, very important topic this one, direct and indirect band gap semiconductors. What are direct and indirect band gap semiconductors and their properties? You have to draw this diagram. As I told to you in theory class, if you want to explain the properties of direct and indirect band gap semiconductors, means compulsory you have to take help of diagrams. Left side whatever is that, that is for direct band gap semiconductor, and the right side whatever the diagram is there, that is for indirect band gap semiconductors. Okay. So here what I am doing, ek relation I am taking, ek graph, energy y axis and momentum values on x-axis. Momentum is nothing but this electron and the hole, both are in general will be vibrated with some frequency. That is nothing but momentum we are calling. It is nothing but the motion of the charged particles will give the momentum value. In direct band gap semiconductors, what is happening, if you take the conduction band as like this and the valency band as like this, in valency band hole is assumed as here one hole, and in conduction band one electron, free electron is like this, you imagine as like this. In general, in direct band gap semiconductor, this is the situation. Whatever the gap is there between the conduction band to valency band, it is called as forbidden energy gap. In general, in this type of direct band gap semiconductors, Eg is greater than 2 electron volts, greater than or equal to 2 electron volts. So that gap is more, and whatever the momentum of free electron is there, it is exactly matching with the momentum of the hole. That's why anytime this free electron can occupy the hole position. It is the downward transition. Due to downward transition, some amount of energy should be released by this electron. That energy is released in the form of a photon, which is nothing but light is going to be given as the output. Since spectral region, that energy gap value is there. Less than or equal to 2 electron volts means heat energy will be produced. Greater than or equal to 2 electron volt is nothing but energy is released in the form of photon. In general, due to matching of the momentum of the free electron and the hole, directly we are getting a photon here. LED is the best example, light emitting diode, in which light photons are released by that downward transition of electrons. So that semiconducting material is a direct band gap semiconducting material. Okay, indirect band gap means this is the situation. This is the situation. Conduction band is here, where one free electron is there, and its momentum value, x-axis value, is higher than the momentum of the hole, which is located in valency band. Momentum of electron and hole are not matching here, mismatched. Due to the mismatching, what is happening? This free electron cannot directly will occupy the hole position unless until its momentum value is reduced. Reducing is nothing but it has to be decrease its momentum value. When it will decrease? By making an intermediate transition here to an another energy level. Okay, then slowly starts reducing of its momentum. When this momentum value is matched with the momentum of the whole position, then it will make a downward transition, and then due to this downward transition it has to release some amount of energy. But thing is, this gap whatever is there between this energy level to this energy level, that value is lesser than the required energy gap to produce a photon. Less value, less than 2 electron volt. Due to that reason, energy is released in the form of some heat. Energy released in the form of heat. Energy have to be released. If lesser amount was released, is nothing but in the form of heat. If greater than 2 electron volt of energy is released, in nothing but in the form of light. Energy in general will be released. Thermal emission or photon emission, we are calling it as. Emitted is nothing but releasing. Okay, so in the indirect band gap semiconductor, this is going to be happen. Example, what can be taken here for indirect band gap semiconductors? Any idea? Already you might have gone through all these topics now. For direct band gap semiconductor, example is LED and semiconductor lasers can be taken, in which light is the output, because of the material which you have selected is direct band gap. For indirect band gap semiconductors, what is that example? Any idea?
Ordinary diode.
Ordinary diode.
Ordinary diode.
Yeah, diode is made up of semiconducting material only. So ordinary diode is also made up of semiconducting material only. That diode will comes under the indirect band gap semiconductor, in which whenever the charge carriers will make the recombination process or the downward transition, slightly small amount of energy is released. That's why that component is going to be get heated up. Heat only is producing. Okay, so that is the example for indirect band gap semiconductor. All ordinary diodes, transistors can be taken. Okay, so the properties can be taken as like direct band gap. List out the properties, very important properties. Just four properties: 1, 2, 3, 4 examples. LEDs, semiconductor, laser, as like this. All they will comes under the direct band gap semiconductor. LED is best example for direct band gap semiconductor, where output is light. Indirect band gap semiconductors, if you take, these are all the properties, and example can be taken as ordinary diodes or the transistors, which are made up of semiconducting material only. Now you know transistor is nothing but back-to-back connection of two diodes. Back-to-back connection of two diodes will results a component called as a transistor. We are having two different types of transistors, PNP transistor and NPN transistor. They were manufactured by back to back connection of the diodes only. NP transistor you take, PN transistor you take, add them together, NPN transistor will form. Okay, PN diode you take, NP diode you take, add them together, then here PNP transistor is formed. That you are going to know in next semester, where when you are studying about the BW. Even I think in BW transistors are there. Is it right? Have you gone that basic things about transistor? Have you studied about the basic things? In BWE, will it come? In BEEE, Basic Electrics, Electronics and Electrical Engineering, in which this will come actually. Transistor, have you heard about this word? A device called as a transistor.
Yes, sir.
Sir, it's Unit 5 transistors there,
Okay,
but it
okay.
has completed yet.
Okay. Basic thing is PNP transistors and NPN transistor. Two different types are there. They will also work based on the diode functionality only. But thing is, at middle they will have one junction actually. By operating that junction, we can use them for conducting and non-conducting purpose. Transistors we are calling NPN, PNP. They were formed by joining back to back of PN diode to NP diode and NP diode to PN diode as like that. Okay, so that is different thing. Okay, so that is about the direct and indirect band gap semiconductors. Next, Hall effect, most frequently asked question in final exam and as well as in the middle, in the mid examinations also. Hall effect. What to be written as answer for given question? Hall effect. First, you need to write the statement of Hall effect. What is Hall effect? Hall phenomena is what? By taking three axes as x, y, z axis, on each axis by applying one parameter as B and another parameter as the current. Then the third axis, whatever is there, if you take three axes are all these are one and each other are perpendicular to one and each other, if you take as a, then something is producing here as the voltage, Hall voltage, which is perpendicular to the magnetic field and the current. Even in yesterday's class, day before yesterday also, you have done one virtual experiment, virtual lab experiment on Hall effect. This one only. Three axis, three parameters, B, I, and V. BI we are applying. B is nothing but magnetic flux. I is nothing but the current across that semiconducting device perpendicular to the B. Then we are getting the Hall voltage in a direction perpendicular to B and I. That is called as Hall voltage, and this Hall voltage is represented by VH. The entire phenomena is called Hall effect. Okay, and whatever the produced electric field is there across that semiconductor is called Hall electric field EH. And that diagram you need to draw. This diagram you have to draw. This diagram only you have to draw by taking three axes, X, Y, Z axis. Okay, this diagram, this is the semiconducting material, three-dimensional semiconducting material. Now, in this direction, I am applying the magnetic field B. Arrow marks you see, and I'm applying the current in this direction. Current is in this direction, perpendicular to direction of B. Then voltage is developed on top and bottom direction. So VH top and bottom direction as like this. This is Hall effect, and this works based on, need not to draw this diagram, just for understanding purpose only. Actually, I have taken this as. But thing is, the actual diagram what you have to draw is this one only. Is it okay? This diagram only you have to draw. Statement, what is Hall effect, what is Hall electric field, and this diagram, and the working of Hall effect. Working of Hall effect means what? Fleming's left hand rule it follows. What is that Fleming left hand rule? And when you apply the magnetic field on charged particles, in which direction that force will be experienced by the charged particles? That follows a rule called as Fleming left hand rule that you have to write. Due to that reason, one type of charge carriers are accumulated on the surface of that semiconductor, and the different type of charge carriers are accumulated other side of the charge, other side of the semiconducting material, top and bottom as like that. Okay, based on the produced electric field direction, we are saying it is a N type or P type based on the sign of EH, which is dependent on RH actually. Okay, so how we can derive an expression for Hall coefficient? This also you have to write. Explain about Hall effect and derive an expression for Hall coefficient. Means this part also should be included. Up to this, RH equal to minus 1 by NE and RH equal to 1 by PE for P-type semiconducting materials. Sign represents the charge, sign represents the type of the semiconducting material, N-type or P-type, based on that. Okay, this you have to write. Current density is equal to, and EH, produced electric field, is directly proportional to B. Produced electric field is directly proportional to current density. So EH can be written as B into Jx. EH is equal to, right, if you write as like this, one proportional constant to be introduced as RH into B Jx. Okay. Now equation 1 and 2, if you take, both are same. Both are same. Equal. Both are same only. So equalizing these two, and get cancel of Jx and BB. So RH we are getting as 1 by Ne. Now if at all the direction is one side, then EH equal to plus side we are taking. If at all EH is opposite direction, the charge carriers are accumulated in opposite direction, then it is taken as the negative sign of EH. Based on that, RH sometimes can be taken as minus, RH sometimes we are taking as a positive sign. So positive, if at all you got, this is for P-type material, P-type semiconducting material. If you got negative sign of RH, it is nothing but representing as a conventional rule as like that. Okay, we are taking it as that given semiconductor is a N-type semiconducting material. This is the diagram, experimental diagram, and this is the derivation for RH. Next, applications of Hall effect are there. Applications of Hall effect. What is that application means? This you need to write. Determine the type of semiconducting material that is based on the RH. P type or N type, we can find out. Number of charge carriers, N value can be calculated. B value can also be measured if at all some amount of magnetic field is present at one particular point or particular place. Mobility of charge carriers can also be calculated as like that. Okay, so one need not to write about this gear, shaft, RPM actually. Up to this you write and leave it. Applications of Hall effect means 1, 2, 3, 4. Just for understanding purpose, I have taken RPM meter and I have explained about how that RPM meter will works. But in exam need not to write about RPM meter. Is it okay? And this will comes under the syllabus for the second mid examination, VI characteristics of diode. So need not to touch this. Up to Hall effect only you can expect as the important questions. So overall, now you tell me, one of you unmute yourself and tell me, in third unit what are the important questions that I told to you. Important questions in third unit, 3A, 3A, mid exam point of view. Tell me what are all that important questions are there. Tell me. Important questions in third unit. Overall, what you have understood. What are the important questions? See, these red color, whatever are there, they are very important for final exam point of view also. N-type formation, P-type formation and properties, direct and indirect band gap semiconductors, direct and indirect band gap semiconductors, their properties and Hall effect. Four are there. These are very important for short answers and long answers. Okay. Even sometimes Fermi level and intrinsic and extrinsic diagrams can also be asked as under the short answer question. Okay. It doesn't mean that formation of extrinsic semiconductors won't be given. It's not like that. But thing is, most of the times we can expect these N-type formation and P-type formation and direct and indirect band gap and Hall effect are being taken as the important topics. Is it okay? Are you listening what I'm saying? Now the question
Yes,
is,
sir.
yeah, now the question is problems. If you take, what problems can be expected in this, that also we will see here. Okay, problems, where actually the problems. Okay, let me go down. Yeah, you see, Once already we have solved these problems actually. Unit 3A, if you take, this is one question which already we have solved virtually last tutorial problem, last session tutorial problems. If you take the intrinsic carrier density, how you have solved means by using these formulas. Have you noted down these formulas that time? Last tutorial, yeah, session, if you take, we discussed about in unit 3 what are the important problems that can be expected in mid examination. Sigma ne into mu n plus mu p, conductivity sigma equal to 1 by rho, resistivity relation, Hall coefficient rh equal to 1 by ne, mobility of charge carriers mu equal to sigma into rh, and energy gap Eg equal to h in u, like that we have taken. Okay, now problems, this is the first problem in its solution. Okay, two problems, these are very very important problems. Thing is, either you will get a problem in Hall effect or in semiconductors. In semiconductors, problems can be expected as to find out the conductivity, find out the resistivity as the values. And Hall effect, if you take RH value, they will give, will ask you to find out the resistivity value. How to solve these problems also we discussed in previous class. Okay, this is the solution. See, this problem solution answer is this much you got. How you got this means this is the formula to be used. Very simple. You see, you are going to get 3 marks for this. 3 marks, 1 2 3 4 lines only are there. This is the final answer. Only thing is you are substituting all values in this expression, where E is charge of electron, Ni is concentration of charge carriers, number of charge carriers, mu is mobility of electron, and mu n is mobility of holes, as like this by taking. So calculation, doing the calculation. Okay. Next, question number 2. This is the question what I asked you to solve. And answer also the day I told. And solution for this is this. Already we have solved these problems in tutorial. Number of problems we have solved. And this is problem 3. RH is given as like this, and resistivity you have to calculate. Resistivity is like this. Find out the mu and n. This is the answer. Answer is what? Like this. A and B are there. RH and mu have to be calculated as like this. Okay. Next, fourth problem. Calculate the wavelength of radiation. Already you know. E equal to h nu. Based on that, Eg equal to, we can write Eg equal to h nu. Nu equal to C by lambda. From that Eg value we are finding as like this. Okay. So these are all the problems already we have solved. And most of the times, maybe the numeric values will vary, but overall these problems can be expected as it is with some small changes of the numeric values. If you have any doubts, you can ask. Now, 3.5 units, 3 days in 1 hour review, doing the reviewing thing means it's a little bit fast only we have to go, otherwise it is not possible to complete. Now you tell me anything you want to ask, you can ask. Here you see, as I told to you, you have to download your hall tickets from student login. I think already you have downloaded. If you are getting any problem, it is nothing but because of two reasons. One is might be you have some feed you, and the second thing is if at all any server is down for some time, you could not download your hall ticket. Only these two reasons. Anybody is facing any problem while downloading the hall ticket? Might be today is last date, or I don't know. Already have posted that message to you. Have you downloaded your hall tickets?
Yeah.
Downloading అయిపోయిందా హాల్ టికెట్స్ చేసుకున్నారు కదా? If at all
Yes.
Yes,
any
sir.
problem is there, just you inform to me. Mean feed you is there means you, that up to you. You have to you have to pay the fee. Nobody can help you. Sometimes
Sir,
what is happening is a server is down. Due to that reason, you could not download. You wait for some time. Why? Because they are doing some maintenance work using by with that server. That's why sometimes it may be down. And now you tell me, Nana, what is your doubt?
sir, timetable morning or afternoon exam?
The timetable is also already posted, na? 10 o'clock to 12 o'clock session is there, and 2 to 4 session is also there. Just you go that top of that timetable there itself you can see.
Okay, sir. Thanks.
Okay. Next, immediately after completion of these mid theory exams, you will have the lab internals. So be ready with your lab records. Complete your corrections. Corrections అయిపోవాలి అని అంటే ఏం చేయాలి? That whenever you are coming for offline these things mid examinations, you bring your lab record and get it corrected by your faculty. All the experiments, and also you ask your concerned faculty about your how many lab internal marks you got. Out of 15 lab internal marks are there. Remaining 15 marks for lab internal exam. Day to day evaluation 15 and internal lab 15. 15 plus 15, 13, 30 marks. Even that mid examinations, if you are writing means 5 marks for assignment are there. If really you have submitted, then definitely you will get full marks. In time submission and quality of submission both are important. Next, anything you want to ask, you can ask. And one more important thing is total, I think 5 students are there. Rule number 1, 10, 33, 34, 35, 34, 35. Like the total 62. 5 students are there whose attendance is less than 65%. When the attendance that coordinators and in charges were calculated that attendance, don't by considering all the issues they have calculated actually by seeing in ERP, and don't say that my attendance is more than 65 as like that. Might be border 64 point something is there also. You have to bring your parent and they have to sign here in an undertaking form. So Monday we are expecting, otherwise you are not allowed to write the exams. Physically, your parent only, not your brother or any relative. Your parent, mother or the father, along with the parent, you have to come to the college and give your undertaking form. Then only you are allowed to write the exam from next day onwards. Don't say any cock and bull stories on that day. Nobody is ready to listen that words. Prior, we are giving all this information to you. Prior only. In advance, we are giving. Later, you should not say that we are not received this information, that information. My mobile is not working. Don't say as like that. Okay. So less than 65% attendance students have to bring your parent on Monday, and matter of 5 minutes they have to sign on undertaking form. They can leave. You can write the exam. Second thing is, without hall ticket and ID card, no student is allowed to write the exam. Don't say that my this ID card I have missed, sir.
The
Or
ID card is not issued, sir.
ID cards not issued means definitely you will get the ID cards. Already printing is over. You will get the ID cards on that same day.
Okay, sir.
Okay. One more important thing is on that day, first day, no one should absent. Absent అయితే మళ్ళీ ఐడి కార్డ్స్ ఇష్యూయింగ్ ప్రాబ్లం అవుతుంది. నెక్స్ట్ డేకి మీకు డిలే అయిపోతుంది. పేరెంట్స్ని తీసుకురావటము ఇది ఇన్ టైం కాకపోవచ్చు. సో ఈ హర్రీలో మీరు ఎగ్జామ్ సరిగ్గా రాకపోయి ఉండొచ్చు. సో సో మెనీ కాన్సిక్వెన్సెస్ యూ హావ్ టు ఫేస్. టు అవాయిడ్ ఆల్ దిస్, Monday you have to attend. Less than 65% students have to attend with their parents. Okay, and bring your hall ticket. Compulsory ID card is also required. One day excuse will be there
Can they
on
come on
Monday.
Saturday?
No, no, you come on Monday onwards. If you
Okay, sir.
if you are near to the college, then it's okay. See, after coming, you are, for example, you are staying so far distance, Karimnagar or some other way, some other district. That day you came and asking me to where I have to stay, sir, means I could not give the answer. If you are very near to college, come and go. Is possible for you, you can come and go. Then you can come. Okay.
Sir, should we come morning itself on Monday?
Yeah, you can come, no problem. You can come morning itself, but see when you have that exam timings, you see, if at all you are having the exam on afternoon session, means you can prepare. You can use the classrooms. All classrooms are free only. First year classrooms are free only. You can sit and you can prepare for the examination. If at all your exam is on in afternoon session. All buses are going to be run from Monday onwards, full fledged. So no problem for you. Transportation. Okay. Anything else you want to ask?
Sir, scientific calculators are allowed in
Allowed,
examination.
allowed, allowed. They were allowed. You can bring your own calcies. అంతేగాని ఆ టైంలో while writing the exam, don't ask your neighbor to give that calci. Don't borrow from others. Simply the invigilator will just you send you out. Don't do like that. Okay. You have to bring your own calci. Calcis are allowed.
Watch,
Scientific calcis.
watch, sir.
Digital watches are not allowed.
Okay.
Means Bluetooth operated and smart watches are not allowed that day. And cell phones are also not allowed in hall. You have to switch off, keep it in your bags. That bags are of your responsibility only. Nobody will take the responsibility of that custodian things. In classroom itself, in examination hall itself, you can keep one side all these bags. Okay, after completing the exam, you can take back your bag. But thing is that cell phone should be in a off, switch off mode or mute mode. Okay, next. This is time to ask whatever you have doubt, you can ask. Whatever the doubts you are getting, you can ask.
Sir, results any days పడుతుంది సార్?
Mid exams result, mid exams,
అవును
you are
సార్.
asking about mid exams, na?
Yes, sir.
It will take 1 week time. Within a week, you are going to get the results. Means, for example, you have four theory exams. First, Monday, Tuesday, Wednesday, Thursday, you are writing the exams. Next Monday, you are going to get the results. When once exam is over, the immediately correction will start by the concerned faculty. Not more than 1 week. Next. అడగండి. ఓ సో మెనీ డౌట్స్ ఆర్ దేర్ నా ఫర్ యూ. ఏమున్నా అడగండి ఇప్పుడు. దిస్ ఇస్ ది టైమ్ టు ఆస్క్ ది క్వశ్చన్స్, క్వైరీస్. అంతేనా? ఫ్రీ అయిపోయారా? మెసేజ్లు పెట్టి క్లాస్ ఇన్ఛార్జిని ఇబ్బంది పెట్టకండి. నన్ను అడగండి డౌట్స్ ఏమైనా ఉంటే.
సార్ ల్యాబ్ ఎగ్జామ్స్ గురించి చెప్పండి సార్.
మండే ఆన్వర్డ్స్, నెక్స్ట్ మండే ఆన్వర్డ్స్. అంటే మీకు ఈ ఎగ్జామ్స్ అయిపోయిన ఫాలోయింగ్ డే, అంటే 21st ఆన్వర్డ్స్ ఐ థింక్. During these exams only you are getting that messages regarding the lab internal exam. ఏం లేదమ్మా, దట్ డే యూ హావ్ టు బ్రింగ్ యువర్ ల్యాబ్ రికార్డ్ కంపల్సరీ. అండ్ 4 experiments are the syllabus. 4 experiments, whatever you have done, 4 experiments are there na. 1 experiment is going to be give to you. You have to write the write up, do the experiment, and take the readings and do the calculation, and final write up you have to submit there itself. Offline only. No online exam will be conducted.
సార్
ఏ డౌట్ ఉందో చెప్పండి. ల్యాబ్ ఎగ్జామ్స్ అన్నారు, దిస్ ఈస్ గోయింగ్ టు బి హ్యాపెన్ లైక్ దిస్. ఇంకేంటి?
సార్ ఇది ఓవరాల్ పర్సెంట్ మనది 93% ఉంటే ఒక సబ్జెక్ట్లో 60% ఉంటే ఎగ్జామ్ రానిస్తారా?
Overall attendance only will be considered. Overall attendance only, subject wise attendance కాదు.
Okay, sir.
On our average, whatever the percentage of attendance that you are getting, that only will be taken as the final attendance.
Okay, sir.
Okay. ఇంకా ల్యాబ్ ఎగ్జామ్స్ మీకు డ్యూరింగ్ దట్ 21st ఆన్వర్డ్స్ ఉంటాయి. మీ రెగ్యులర్ అవర్స్ ఏవైతే ఉన్నాయో, రెగ్యులర్ అవర్స్ అంటే ఫర్ ఎగ్జాంపుల్ మండే, ఫర్ ఎగ్జాంపుల్ యూ టేక్ మండే ఫస్ట్ 3 hours you have AP lab. During that 3 hours only you will have that lab internal exam. ఇంకా స్పెషల్గా మీకు టైం టేబుల్ అంటూ ఏముండదు ల్యాబ్ ఇంటర్నల్ ఎగ్జామ్స్కి. 21st onwards, 21st whoever is having the lab, they will have that lab internal exam. రెగ్యులర్ టైం టేబుల్లో ల్యాబ్ అవర్స్ ఏవైతే ఉన్నాయో అప్పుడే ఉంటుంది. ఈజ్ ఇట్ క్లియర్? మండే
Remaining classes are same, sir. Remaining classes.
క్లాస్ వర్క్ సేమ్. మీకు ల్యాబ్ అవర్స్ ఫర్ 3 hours నా మండే ఫస్ట్ 3 hours ల్యాబ్, యు ఆర్ రైటింగ్ ది ల్యాబ్ ఇంటర్నల్ ఎగ్జామ్, అండ్ ఆఫ్టర్నూన్ ఆన్వర్డ్స్ యూ విల్ హ్యావ్ ది రెగ్యులర్ క్లాసెస్.
సార్
చెప్పు.
మండే రోజు క్లాసెస్ జరుగుతాయి సార్, ఓన్లీ మిడ్ డేనా?
డిస్క్రిప్టివ్ ఎగ్జామ్ ఉన్న రోజులలో మాత్రం క్లాస్ వర్క్ ఉండదు. ల్యాబ్ ఎగ్జామ్స్కి మాత్రం క్లాస్ వర్క్ ఉంటుంది. డిస్క్రిప్టివ్ ఎగ్జామ్ మీకు మండే నుంచి స్టార్ట్ అవుతున్నాయి కదా, మార్నింగ్ ఆఫ్టర్నూన్ మీకు ఎగ్జామ్ ఉంది అని అంటే సెకండ్ సెషన్లో మీకు క్లాసెస్ ఉండవు. యూ హ్యావ్ టు ప్రిపేర్ ఫర్ నెక్స్ట్ ఎగ్జామ్. అవర్ ఇంటెన్షన్ ఈస్ నో క్లాస్ వర్క్ డ్యూరింగ్ ది మిడ్ ఎగ్జామినేషన్స్. ఓకేనా?
ఓకే సార్.
ల్యాబ్ ఎగ్జామ్స్ అవుతుంటే ఆ వీక్లో మాత్రం ఆ కన్సర్న్డ్ ఏదైతే ఫ్యాకల్టీ ఉన్నాడో, ఎప్పుడైతే మీకు ల్యాబ్ ఉందో, ఫర్ ఎగ్జాంపుల్ బీట్రిపుల్ ల్యాబ్ ఉందా మీకు? ఐఓటీ ల్యాబ్ ఉంది కదా, ఐఓటీ మీకు యాక్చువల్గా ఆ వీక్లో ఎప్పుడు ఉంది? ఫర్ ఎగ్జాంపుల్ ట్యూస్డే ఉంది అనుకోండి, లాస్ట్ 3 hours అనుకోండి. లాస్ట్ 3 hours యూ విల్ హ్యావ్ ది ల్యాబ్ అండ్ ఫస్ట్ 3 hours యూ విల్ హ్యావ్ ది థియరీ. దట్స్ ఆల్. డ్యూరింగ్ డిస్క్రిప్టివ్ మిడ్ ఎగ్జామినేషన్స్ అప్పుడు మాత్రమే మీకు క్లాస్ వర్క్ ఉండదు. ఓకే, నెక్స్ట్ అడగండి, టైం అయిపోతుంది. ఆల్రెడీ 3 o'clock. ఏం లేవా? అంతేనా
సార్ రెగ్యులర్ క్లాసెస్ ఏనా సార్?
అమ్మా? అర్థం కాలే మళ్ళీ.
ఎగ్జామ్స్ అయిపోతున్నాయి కదా సార్ వెనస్డే వరకు.
అవును,
థర్స్డే అండ్ ఫ్రైడే రెగ్యులర్ క్లాసెస్ ఏనా
ఎస్,
సార్?
రెగ్యులర్ క్లాసెస్. నో గ్యాప్ విల్ బి గివెన్ ఫర్ థియరీ అండ్ ల్యాబ్స్. మీకు ఇమ్మీడియట్ ఫ్రైడే నుంచి మీకు రెగ్యులర్ క్లాసెస్ ఉంటాయి. ఇంకా డోంట్ టైం ఏం వేస్ట్ చేయరు. ఇంకా 4 ఎగ్జామ్స్ అయిపోగానే నెక్స్ట్ డే నుంచి క్లాస్ వర్క్.
Sir, is there any pass percentage for internal exams?
Pass percentage is 50%. Out of 30, 15 marks you have to get. Minimum 15. 15.
Okay, sir.
ఇంకా
సార్ ఎగ్జామ్స్ 3 ఉన్నాయి కదా సార్ థియరీ ఎగ్జామ్స్ మాకు?
అవును, మండే, ట్యూస్డే, వెన్స్డే ఉంటాయి. థర్స్డే నుంచి మీ క్లాస్ వర్క్ స్టార్ట్ అవుతుంది.
ఓకే సార్.
నెక్స్ట్
సార్ సీటింగ్ అరేంజ్మెంట్ ఎప్పుడు ఇస్తారు?
మీకు మండే మార్నింగ్ మీకు వచ్చినప్పుడే మీకు బయట హాల్కు ముందే ఉంటుంది. మీకు ఏ హాల్లో ఏ స్టూడెంట్స్ కూర్చుంటున్నారు, ఎక్కడ బ్రేక్ అవుతుంది, ఫస్ట్ 20 స్టూడెంట్స్ ఎక్కడ కూర్చోవాలి, నెక్స్ట్ 20 ఎక్కడ అనేది బ్యాచ్ వైజ్గా మీకు 9 o'clock పేస్ట్ చేస్తారు.
థర్డ్ ఫ్లోరా సార్?
Yes, third floor only. Your classrooms only. In your classrooms only, but not exact your classroom. Others classrooms are used to conduct the exams. మీ దాంట్లో ఐటీ వాళ్ళు కూర్చోవచ్చు, మీరు వెళ్ళి ఐటీ వాళ్ళలో కూర్చోవచ్చు. అలా ఉంటుంది, బంబ్లింగ్ ఉంటుంది. అంటే రోజు ఒకే దగ్గర కూడా కూర్చోరు. దట్ విల్ బి డిసైడెడ్ బై ది ఎగ్జామినేషన్ బ్రాంచ్. ఎవరు ఎక్కడ కూర్చోవాలని ప్లానింగ్ అంతా సీటింగ్ ప్లాన్ ఎగ్జామ్ బ్రాంచ్ వాళ్ళు చేస్తారు. ఆల్ 3 ఎగ్జామ్స్ మాత్రం ఒకే చోటమైతే కూర్చోరు. రూమ్స్ చేంజ్ అవుతుంటాయి. ఇంకొకటి, డ్యూరింగ్ దీస్ మిడ్ ఎగ్జామినేషన్స్ ఎవరు కూడా మాల్ ప్రాక్టీస్ కింద బుక్ కాకండి. వాట్ ఈజ్ మాల్ ప్రాక్టీస్ ఇన్ జనరల్? ఏంటమ్మా మాల్ ప్రాక్టీస్ అంటే ఏంటమ్మా?
స్లిప్స్,
Cheating.
కాపీ.
Lips copies.
కాపీయింగ్, చిట్స్ తీసుకురావటము, క్యారీయింగ్ ది చిట్స్ ఆల్సో, చిట్స్ ఈజ్ ఆల్సో మాల్ ప్రాక్టీస్ ఓన్లీ. నేనేం రాయలేదు సార్, కానీ నా జేబులో ఉండి వాడు పట్టుకున్నాడు ఇన్విజిలేటర్ అని అంటే ఇట్స్ నథింగ్ బట్ విల్ కమ్స్ అండర్ ది మాల్ ప్రాక్టీస్ ఓన్లీ. అండ్ సెల్ ఫోన్స్ క్యారీయింగ్ ఇన్ ల్యాబ్ ఎగ్జామ్స్, డోంట్ డూ సచ్ టైప్ ఆఫ్ థింగ్స్. వాట్ ఎవర్ యూ హ్యావ్ ప్రిపేర్డ్, వాట్ ఎవర్ యూ నో, దట్ యూ రైట్, దట్స్ ఆల్. ఓకేనా? ఇంకేమన్నా క్వశ్చన్స్ ఉంటే అడగండి.
సార్ ఈచీ ల్యాబ్కి డేట్ ఇవ్వలేదు కదా సార్?
ఏంటమ్మా దేని ల్యాబ్కి?
ఈసీ ఎగ్జామ్ సార్, ఇంజనీరింగ్ గ్రాఫిక్స్ ఎగ్జామ్.
దట్ డే దట్ మీన్స్ యూ వెన్ యూ కమ్ టు ఫస్ట్ టైం అంటే మండే మీరు వచ్చినప్పుడు ఒకసారి సబ్జెక్ట్ ఫ్యాకల్టీని కలవండి. డ్యూరింగ్ ఇన్ జనరల్ వట్ ఎవర్ ది ఎగ్జామ్స్ ఆర్ దే, ల్యాబ్ ఎగ్జామ్స్ ఆర్ దే, దే విల్ బి కండక్టెడ్ ఇన్ రెగ్యులర్ ల్యాబ్ అవర్స్ ఓన్లీ. ఆల్ ల్యాబ్స్ ఆర్ లైక్ దట్ ఓన్లీ. అదర్వైజ్ యూ కెన్ కాల్ హిమ్ అండ్ యూ కెన్ ఫైండ్ అవుట్ ది డేట్ ఎప్పుడు అనేది మీరు అడగండి. కన్సర్న్ ఫ్యాకల్టీని అడగచ్చు. రెగ్యులర్గా క్లాసెస్ అవుతున్నాయి కదా మీకు. Okay, now I'm posting the today's attendance kosamu. Let me post the link. 8888 is the code. 8888.